React, about building applications with a modern stack. I'm really happy to have you here today. I am not going to be showing you very much about React itself because, well, you're at a React conference and you're going to be seeing lots and lots of talks all day about React. I'm going to show you a really interesting tool called Hasura, and I want to make the argument about how this will really help you be able to build quicker, better, faster applications. Now, this is going to be a bit of a fast, quick run through about what Hasura is. I have a workshop in a couple of days on this actual topic, on this actual project. So what I want to do is more just show you some of the sneak peeks about how these pieces kind of come together. And then with that being said, we'll be able to actually go into a deep dive on that in a couple of days. So I would really encourage you to join me for the workshop. It's before the actual event itself, so you're not going to miss any of the good speakers, but I think you're going to really enjoy it. And yeah, let me give you a quick understanding of what Hasura actually is. And I think the best way to understand it is sort of there's two pieces of it. One is there is the data layer, and then there's sort of like this data plane. And the data plane is sort of the configuration, the metadata, the connection of pieces together. And then Hasura, as the data plane, is where the actual pieces come together. So it's where the data layer is where the pieces come together. We define relationships, you define how things work, and then you get access to this API. But it's a bit more fancy than that, because what it does is it actually auto-generates the vast majority of your API when you give it a Postgres database. You say, here's my database, and then you get this API for free, which is a really cool feature, because 99% of the CRUD that you're going to be doing in an application, and I mean that with capital CRUD there, of the application building will be updating tables, deleting items, inserting new items. These are solved problems, and when you're able to auto-generate the majority of that code, then you're going to be able to work really quickly because you get an API quickly. You can enable your permissions and say, these roles have access to this, and those roles don't have access to that. And then you're able to actually layer on just a little bits of business logic on top about what makes a difference for your application. We'll talk is great, but I want to show it to you, so I'm going to move on here quickly. My name is Jesse. I'm one of the developer advocates here at Hasura. I will put my Twitter handle up here in the corner so you can find me there, and I will give you some access to the Hasura stuff down here on the bottom. If you have any questions, reach out to us, Discord, Twitter, wherever, you'll find us. All right, that being said, let's have a look at the actual project that we're going to be working on. I'm just putting on the finishing touches for this project. Let's have a quick peek over at the project that we're building. And so you're probably all familiar at this point with Wordle, right? So you've got this sort of a code, an input word that you have, and you have to guess the word. And then at some point, it'll give you a feedback. It'll say, okay, this letter was in the right spot, but was the right word in the right spot, and so you'll get like a green light. And then this word was a right letter, or this letter is a right letter, but in the wrong spot, and then it'll actually give you like a yellow light, or you're just way off, and it'll give you an error. And you have, I don't know, 5 or so chances to guess the word, and then you can see your score stacking up on the guesses. Well, there's some interesting pieces happening there. This pattern of game, I believe, goes back to one of the original formats called Mastermind, which is where you would have some sort of a code. I think code breaker is a more common term for these days. But you have essentially a code, and then you're able to give it an input of what you think the code is. There's a code complexity for how many possible color options there are. Think of those as the available letter set, and then you would get a response as well. What I wanted to do was sort of recreate the code breaker version, following on Wordle's very impressive success. And that being said, I have some patterns here generated. I think they're rather pretty. So we're going to go ahead and have a quick look here at what happens when we sort of try to make a guess on one of these games here. So I'm going to go ahead and I'm just going to pop in some of these codes here. And I have an authenticated environment here. I'm going to go ahead and I'm going to hit guess. And then what's happening under the hood, you'll see that at the bottom there a little code just popped up. Well, that's not actually representing the set of data that I have that I gave in. I gave it, ones and threes and twos or whatever else I've associated with these patterns. This is actually a real-time subscription that is coming from my evaluation server, where I give it my set. I say, okay, this is what I think the code might be. And in my case, it's going to actually say, well, 2 is a right letter, wrong spot, or right number, wrong spot. A 0 is totally off. A 1 is on the money. So what I can see here is that I have my last 2 totally correct, but it looks like my first 2 are incorrect. So if I were to maybe try to guess which one was here, I totally forget which one I'd used there. But maybe we could actually do something like, we'll do another of these herringbone patterns, and we'll see what we get with that. Give it another guess here. It appears maybe I gave it the exact same. We'll do another guess here. And looks like I'm getting nowhere near. And so there we go. So that was the correct one we have there. But boy, am I really close to losing this game now at this point, because I've got an actual set of 5 chances. I have told my algorithm that for the code complexity, I get, or for the code length, I get a guess per length. Well, 5 slots and 4 guesses, looks like I'm not going to have a very good shot at actually figuring this piece out. So anyways, that's the game. It's a lot of fun. We'll be having a look at this inside of the workshop. Please don't play the game during the workshop, or do, I don't care. But we'll have a lot of fun with that. So anyways, what I wanted to have a look at here is, cool, like we have this project that's working. There's some interesting pieces happening here. We have real-time subscriptions. We have basic CRUD behaviors, inserting guesses. We have custom business logic happening, right? Because I'm doing an evaluation. So it's not just generated APIs on my Postgres database. It's also some sort of custom behavior coming in. And we've got like an authenticated environment where I'm actually able to scope down based on my user. Like, those are a lot of really fascinating pieces, and it actually only took a little bit of time to kind of snap that together. In fact, the thing that you're going to discover with Hasura is that the vast majority of time will not actually be in Hasura. It'll be in building in React and building these other paradigms. And that's exactly what we actually think is important. And this is why with Hasura, there's a really important concept to bear in mind, and that is that everything gets lifted up to server state. So my authentication API would be lifted up into the server as an actual API endpoint. My other business logic, my analytics, everything else, all gets lifted up so that I'm still shipping that one API to all of my clients. In this case, it's a React client because it's a React conference. And I can ship this to my React Native people. I can ship this to my Flutter people, I don't know. So if you have other sort of paradigms you're having to build for, I can ship the single API, and then it's simply a question about implementation. And that's why I didn't want to actually focus on React today, because this is not a React project per se. Of course, it's React code. It's using Next.js because Next.js is fantastic. I think they're running the other workshop. But like, this is actually a really interesting tool that allows us to be able to say, I don't really care about your framework. I don't really care how you're building applications. Here's the API. Here's a well and reasoned about structure that you're able to build applications quickly with full support for custom business logic, for CRUD behaviors. It is like the ultimate backend for front end, if you will. But I think that topic is so well beaten to death these days. We're not gonna worry on that. So, anyways, let's have a look at just kind of how these pieces come together. And we're going to sort of see a little bit of the sneak peek sweet developer flow that we'll be going into later on in the actual workshop. So let's have a look. Basic Postgres project here, right? We've got a table for game, we have a table for user, we have a table for user game, we have a table for user guests. So join tables and actual entity tables. You know the drill. Now, what we have here underneath one of these features here, let's go to the actual user game here. And we have the ability to look at the relationships. Now, these relationships are auto-generated again based on the foreign keys that I've identified in Postgres. It says, hey, I think you actually want these two to talk to each other. And when we say, yes, that's in fact correct, we can see that we have that the user game is able to access the game table, the user game is able to access the user table, and is also able to access the user guesses table. Well, in GraphQL land, which is what the API that we get is, and we can see here I'm testing out my authorization tokens with a bearer token here. Let's go ahead and turn that off and just use the admin here in this case to be able to just get full access. Let's go ahead and see what happens if we go to one of those user game fields. So let's make sure we write a correct GraphQL query. We have user game, when I can type, user game, and then we're going to go down. We can actually see the game information. In this case, we can actually see the code. We can see the code complexity. Let's go ahead and grab the actual user that's on this game here. We can actually see their identifying hash that I've created. We can even see that their total user guesses for all games that they've actually guessed on. Maybe we can discover there's a pattern of some sort of a default that that's their go-to, right, for their first guess every time. I know some Wordle players have their first word guess. Yeah, we get GraphQL, right? This is what we really like about GraphQL because we're able to get descriptive. This could be a single query somehow, and I don't have to go about reaching back and forth to my API over and over again. Well, this is all well and good, and this is the relationship pieces, but this is just just the tip of the iceberg in terms of what we're able to do. So here we have this standard CRUD behavior that we're able to analyze foreign keys. But when it comes to actually building an application, when it comes to building my sort of Myrtle's a bad name for a portmanteau on Wordle, but like when it's coming to build my application here, I have a couple of things that are like business logic, right? I have like how I evaluate guesses, how I am able to actually show scores, or some of the different paradigms that I want to surface. Well, so how would I go about implementing something like evaluating scores? Well, here, and if you know Postgres a little bit, and we're really not going to be going into this in a lot of depth, but if you know Postgres a little bit, you'll know Postgres has things like events. And if I go over to the events category, and I want to also focus here that this is not just Postgres. We support a wide array of databases, BigQuery. We're getting support for MySQL. We're getting support for so many other database types that really you can bring in all these databases and make joins across them and be able to make relationships between these different sources, bring in other GraphQL schemas, and build a very rich graph of data. But in this case, what I need to do is be able to actually go to my events, and I'm going to say I need to handle a guess on that event. And so what I'm going to say is that basically what happens is that I've identified that the trigger name is handle guess, and the table is the user guess table. And anytime that actually gets a new entry, I trigger this operation where I'm calling a special URL endpoint, and it goes over and it fires this payload over to my endpoint. So it says, okay, every time that I actually get a new guess, let's go ahead and shoot over to the API event handle guests, and then handle guess, and then it goes and it runs that code. And we'll look at the code here in a second. And I can actually just forget about it at that point because I have subscriptions. So what I can do is I can say with these building blocks, I'm going to be very eventful on one side where I just trigger off these updates to my database. And then on my database, I'm looking for these events, and I handle them as events. And I'm running all this code and firing these off at my event handler, which scales wonderfully. And then on the front end, I can just say, yeah, so I'm just going to kind of sit back and subscribe to any updates that would come back. So whenever my processor says, okay, yeah, we've got these new events that have occurred, it shoots that data back over to Postgres using, again, the same GraphQL API at the endpoint as I am using on the front end. So on both server and client, I can use the same GraphQL API, and then I get my data back. And then I'm able to actually be able to see those updates, which we saw in the game where the evaluation was coming back in, which is just a really fantastic feature. If we were to even have just kind of a quick, let's iterate just very briefly. We'll show the original input code here. So this is on my index page here. And I'm going to go ahead and open up a specific file, and that is going to be my game score file here. And let's just go ahead and iterate on this really quickly, where we're going to pass in not just the game result code, but we're going to pass in the actual guess itself. Now you're going to kind of wonder a little bit where this data is actually coming from, because it's sort of like not visible here, right? We don't see GraphQL on this page here. You can see that I've hard coded some variables. We'll talk about that during the workshop. Anyways, we're going to go ahead and see if I go ahead and make one more guess here. So it looks like I'm failing. I can kind of see my inputs and my outputs there. If I cared, I would take some time to try to think about this in an intelligent way. But we're going to go ahead and run, in this case, we'll try that one. And so we're going to go ahead and hit guess. And we'll see that the data that comes back from the server is updating relatively quickly. Actually, it was actually too fast for us to see a difference. But sometimes those processes might be longer running, right? So I may actually have my first input, the input code that I've provided it. So in this case, 1123. And then I get the result back, or 11123, sorry, and then I get the result back maybe a couple of seconds later, because maybe I'm using a really cheap host and I haven't paid for scalability or whatever else it might be. So in this case, I can get my access to my code really well. So anyways, I've lost this game, so we can go ahead and skip this part. But I wanted to show you kind of where this comes into a lot of power. So we've got this ability to iterate. We've got this ability to have these event triggers. But like, how does this make a difference now for us as React developers? How can we use the stuff that we know about React and the stuff we know now about having sort of a simplified backend to be able to kind of, as they say, spit nails and be able to really build applications quickly? Well, that's what we're going to be talking about next. So if we head over to our actual code project, now we've talked about the Hasura interface, and you'll see that all these configurations and things, they kind of are specialized. I'm running this locally because it's an open source project, and I can see all of my code that's being defined and modified here. But what's something that's really fascinating that's happening here is that if we look now over at the code base, and if you look here, we'll see we actually have a Hasura folder and a www folder. So this is the root project, and again, we're doing all this in the workshop together. But like, what's happening in these two locations? Okay, so we're in the code land now. Well, Hasura itself is actually running inside of Docker. Okay, so I've got this Docker configuration file defined here. It's got basically all my services. In this case, just a Postgres service and a GraphQL engine. That's the Hasura core product. And it boots it up, and they're running in Docker. That's all fine and good. Well, what's going on with this Hasura folder here? This folder is actually tracking all metadata that I do inside of Hasura. And this is a really, really powerful functionality, because what we can see here is that as we actually go through and we want to make any changes to the Hasura interface, so if we want to connect this data source to that data source, if we want to make a permission change or update rules and anything else, all of that metadata now becomes tracked inside of this system. And if we know anything about tracking of files inside of projects, we know that what this allows us is to be able to use version control, and we can actually now share the exact same configurations from one developer to the next developer and be able to work on independent feature branches and implementing new functionalities and then merging those into main. And like, that is the flow, right? So now I can actually ship this project as a standalone GitHub repository, and we will in the workshop, and now anybody can iterate on this. And they have access to the exact same configurations. They can modify things. They can say, hey, check out this branch where I modified some of the metadata. Somebody can check it out and take a look and see what the behavior is. They can do conflict handling. Like, this is awesome, right? This is how we actually love to build applications, is now everything we've configured, the whole way we've defined the entire project, all here in metadata, and it lives very nicely and neatly right next to our other front ends. Well, let's have a look at the front end here. So again, this is using a Next.js project. And the specific reason we choose that, and for the workshop we choose that, is very, very specifically because of the pages directory with the API routes. And if you know a little bit about Next.js, you have this idea that anything inside of an API folder becomes a serverless function. And so if you're talking about needing event handlers or even maybe actions, which are callable resolvers from the front end, we'd be able to actually persist these next to our code and be able to reuse a lot of maybe clients or other paradigms that we've been developing, algorithms, whatever else, and be able to use those front end, back end. And so while my front end is actually calling over to Hasura, the Hasura is calling back over to my front end, but my back end, because it's my hosted functions. And so I'm not actually calling the API routes from my front end. I'm using that as the back end, and I could port that project to a mobile client and completely forget about all the front end, and I still have the benefit of my hosted backend functions. And so Hasura is still able to communicate to my backend functions, even though it's coming from a mobile device or it's coming from an audio target or something else, your Tesla interface. I don't know if you're playing Code Breaker while you're waiting for the car to charge. Could be. So a lot of different possibilities here where we're able to abstract out these different pieces of our system. The front end just becomes a lightweight wrapper and access point for using this API that everybody else is accessing. Okay, so that's a lot of talk. Let's have a quick look at implementing a very specific feature. And in this case, I want to implement the feature of a login behavior. And so what we're going to need to do is we're going to be able to actually have a query that will allow us to mutate a new user. We need to be able to actually get back a token, pieces on top of pieces that we need to construct. How fast can we be able to do this? So to do that, I need to do a quick config. All right, and we're back. So you'll see now that my application has changed just a little bit. I have a auth wall inside of my application where I have to actually click Let's Play to create an account. Now, I'm not actually tracking any user identifiable information inside of this project. It's literally just creating kind of a fingerprint of user device and IP address or whatever else I can kind of get my hands on, and then I just generate a random account that basically persists as long as you really care to kind of keep being active, playing the game, and then it goes away. So there's no real high score looking back over time. It's just long enough to basically last you through a number of games, or at least one game where all the guests will stay consistent. Just putting this token inside of a local storage. These are implementation details. We'll kind of go over them in the workshop, but they're not actually critical to understanding how this is working. Because what's critical to understand, how do I get inside of my API the ability to actually now take a login mutation or a sign-up mutation? So let's see how we would actually implement this. If I go over to Hasura now, what I have here, and I'm going to remove this query that we're working with, what I want to do is essentially have access to a sign up mutation that would be at the top here. Like I would want to come in here, I could type in mutation, and then I do something like sign up, and obviously I don't have anything. So let's do a action. And an action is essentially similar to events in that they are handling code or bespoke code on a different endpoint at a server or some sort of hosted function. But specifically with an action is going to allow me to kind of have a custom resolver, if you will. So let's go ahead and create one of these now from scratch. And what I'm going to do is I'm going to go ahead and define on top of my mutation field here, which is the top level field of GraphQL. This is how you sort of define top level methods, if you will. You have queries, mutations, subscriptions. I'm going to go ahead and say I want one that's going to be called sign up. And that sign up is going to actually take a input, which is going to be my hash for my user. And it's going to allow me, actually I'm not going to even need to use the hash here in this case, because I'm going to get that from my endpoint. So actually in this case, it's going to be even more simple. It's going to be more simple in this case. Actually, all I'm going to do is just have a method called signup. That's all it's going to do. It's going to actually, the request itself will generate the token. And I'm going to go ahead and now say that the output that I'll be looking for is going to be actually called signup output. And that signup output is going to actually be a type here that I'll define. And all that's going to be on there is just a simple column or a simple root called the token, which is just the token that I'm getting a JWT composed of the hash and a couple of things, nothing fancy. It's essentially the JWT that Hasura is expecting, because I have a handler for JWTs inside of my Hasura config, and so it just says look for my authorization bearer token, look for these roles that maybe I've identified, and I can do some permissions. We'll see that here in just a minute. Okay, so I have this basic behavior here. What I want to do now is actually pass in a environment variable here that I've already defined, which is called, in my case, next URL. This is part of my configuration, going back to that control plane, if you will. And so we have the next URL, base URL for my handler. It's just localhost 3000. It allows me to sort of differentiate between cloud environments. And now I have essentially all I need. I'm going to go ahead and pass my client headers, because I'm actually scraping some of those headers from the request from the user, like their IP address and things, and I'm using those for my fingerprint. So I do want to forward the requests to this mutation to my handler. Also useful for a lot of auth environments. And now I'm going to do a request options transform. We could do a lot of things here. We can map this to a specific REST endpoint if we have one already existing. If you had another auth service and had a specific REST endpoint, you could just pump this data over there and you'd be totally ready to go. Like, you wouldn't even need to do any sort of custom handler. You could just bypass that part. In my case, I've written my own, so I'm going to go ahead and do my specific behavior here. I'm going to put a post request on this, and I'm just going to go ahead and call my endpoint, which I happen to already have on my clipboard. Isn't that handy? All right, so we're going to go ahead and have a quick look over this. It looks like we got everything set up. We're going to do the sign up mutation. We're going to return a token. We're going to call this API endpoint. Everything should be happy. There's no inputs to this at all. It's literally just calling this endpoint. We'll go ahead and create action. And just like that, we now have the sign up. What's cool is if we actually go back over, look at the metadata, just to kind of have a little peek in here, we can see that on this actions GraphQL here, we can actually see that we have our sign up output and stuff already defined, part of our schema that we were defining. So you can kind of see that real-time connection between the metadata is occurring here. All right, so we have this data set up. Let's go ahead and have a look at our code here. We're going to actually look at that sign up behavior here. It's actually an action. I just, as a matter of sort of convention, I kind of like putting things behind, API/actions for actions / events for events. What's going on here? Okay, so we have the request coming in. This is where the start of the handler occurs. We're grabbing an IP, a user agent, and sort of a timestamp, making a fingerprint out of that, and then we are calling our API from our server. So user result, we're going to actually insert a user in our table with the hash that we've just created, and then we're going to take the result of that user and actually formulate a JWT, and then we're going to return that back, the JWT token, back to the server. We're not actually saving the token in this case. We're in the database. We're just using the hash as a lookup for the user. So we're creating a user with the API and sending it back. Okay, cool. Let's have a look at that, see if that works. So we go over to API now. We're going to go ahead and kind of refresh this page. And now we'll see that it's still giving me a note, but it's saying that because it's actually looking for a token. So if we go ahead and run this, great. That's actually working. So we actually have a functioning endpoint. That's great. Now, one thing worth noting here, like, this is well and good, but like, I'm not always going to be having my master or my admin secret here to be able to create users. So let's try this again, and we're going to see, oh, we have a problem here because I don't actually have access to this method. If we go back over to the actions real quick, we're going to add a permission on this. And we're going to go ahead and say permissions on the anonymous role here, another thing that I've configured inside of my Docker file. I'm going to go ahead and hit save. That allows anonymous users to have access to my project. So I go back over to my API. Let's go ahead and we can see that it's even shown up now as something that's available on my introspection. If I run that, we can see I actually have access to creating users now from an anonymous user. Okay, really cool. Now, what's actually happening here under this hood, and how would I implement this in my code? So we're kind of seeing that I've got some funky code going on here, right? So client.mutation, create user mutation, hoopla, and ultimately in here inside of my login is where I really want to be able to handle this behavior under my handle login code. Well, like, I don't have anything, right? Like I want to have something kind of like client query or whatever else. Well, here's where we actually get into some pretty cool stuff, and we're going to leverage a tool called GraphQL CodeGen, and we're going to do a TypeScript CodeGen. So we just take a quick step over into my running infrastructure here. We have my metadata being run over here in this window. We have my front end running over here, and then I'm going to go ahead and run a yarn generate command, which will actually generate a look at my schema, look at all my available code. In this case, it's not done anything because I forgot one crucial step. I'm going to go here under my queries, and I'm going to define a new query here called signup. And under signup, I'm going to paste in a specific query that we were just using. This one over here from our endpoint. This one right here. So we're just going to copy this, take this over. We'll give this a name. We'll call this signup, and we'll do that. Run back over to CodeGen. And it looks at all of the, did I hit that correctly? I don't think I did. Let's try that one more time. And then what it's going to do is it's going to have a look at all this code that was here inside of this query, and it actually generates now really useful utilities, such as if I come up here to my imports, I'm going to import from my generated code, and we'll import from the generated folder here. But what I get to use now is I could have use create or use signup. Use signup mutation. And this is the hook now that actually Urkel is creating for me. This is the client that I've chosen. There's no other reason beyond why I've chosen it other than I chose it. Like I could have been anything. Here we'll do something like const, and we'll say we'll call this the data is the first piece, and then we'll use the execute, or we'll call this sign up as the actual mutation we're going to call, and then we just run this mutation there. And so with that, I can take this action here. This is now callable. I'm going to come in here, and I'm going to say that when somebody clicks on this, we're going to just simply await the sign up, and then in this case, I'm going to do I'm going to do this. I'm going to call this result, and then I'm going to say const data is going to be coming off of that object here. And what I'm going to do here as well is I'm going to actually just unblock those because they're part of my application logic that'll actually hide and show login forms. Okay, so now by defining my action, putting it inside of a query here that I want to reference, and then generating a handler, I've gotten a free hook out of it that has data, it has errors, it has all of the different kinds of behaviors you would expect. We come over now to our field, and we're going to go ahead and just test out that login behavior. And we have login. So that's the benefit, right? That's the whole picture of Hasura. Defining our APIs, defining the custom business logic, defining the things that we need to handle, and then be able to expose those and leverage then GraphQL with TypeScript and that really great relationship those two have to be able to give us just a really great developer experience. I can come in here, I can audit all of the queries that I have. I could actually generate sort of an allow list for my server and be able to actually say only those ones are even allowed to come through. It's a really great way to be able to sort of lock down, configure, and have just a really fast developer experience. I am like so far, like I think out of time. I'm going to go ahead and end it here. That being said, if this is interesting to you, if this kind of flows and you want to see how we build this from the ground up, join the workshop. It's going to be a lot of fun. There will be some information in the chat or the links where you can be able to find that. This is going to be the presentation style, a lot of fun. We'll talk a lot. But that being said, yeah, it was a lot of fun giving this presentation. Thanks for having me. I will see you all hopefully soon. Enjoy the conference and have a great rest of your day. Bye.
Hi, I'm Curtis Robinson, front-end developer at Course Hero. I'm going to talk about anchors and buttons because CSS is awesome. So when should you use an anchor and when should you use a button? And how do you convert to button? Can be tricky. Example, div should be an anchor. I'm sure we've seen something like this before. It's a div and it has an on click that sets the window location. It's bad for accessibility. You can't right click to open in a new tab. You can't hover to see what the URL is or if it's taking you anywhere. Here's one with a button. So slightly better because the HTML reads like it's clickable, but it still has the other problems. So we just change this to an anchor and it has an on click and a href. And now it's all good. It's all accessible. The on click will still fire. That's easy. Here's an example where an anchor should be a button. I'm sure we've seen this before too, where the href is just empty or hashtag, and it actually just shows a modal. It doesn't change the URL, so it shouldn't be an anchor. So we convert it to button. Seems easy, but we got to make sure we style the button. So here's convert to button challenge 1, where we have a 99 pixel tall anchor and it has the text align on the bottom. Can we just change it to a button? Well, it is easy on Chrome. Here is 2 buttons, both 99 pixels tall, one where text is bottom line and one where it's center line. And it looks accurate. But what about on mobile Safari? So on iOS 15, it looks pretty good, but then after you tap the top one, it becomes a circle. I don't know why. Even if you set border radius 0, it still becomes a circle. And then on iOS 14, they're both just circles. iOS 13, here the height doesn't even work. Even if you do display blocks or not, it doesn't work. And iOS 13 is only 3 years old. It was the newest iOS until less than 2 years ago. And of course, here we support iOS 12 and up. So how am I even testing on all these old iOSs? Well, option 1, you can have a giant pile of phones like I do. This is my current pile. This doesn't include family members' phones that I can borrow, just mine. Option 2, if your work has a pile of phones, that's good. Course Hero HQ has a big pile. Option 3, browserstock.com works really well. Here's these 3 pictures I got from BrowserStack, and I tested them on my phones. They're accurate. So the fix. CSS frameworks will normally add a bunch of things that remove all the default styles from buttons, or they'll do WebKit appearance none. Both of these will solve these problems. So there's a lot of styles that browsers add by default. You gotta remove them, and you gotta add your own styles. And but one funny thing is browsers don't add cursor pointer by default, and we normally think anything clickable should change the cursor. Why isn't that default? So early internet buttons were all rendered by the OS. You couldn't style them at all, and they already looked clickable. The only reason that cursor pointer was invented was because anchors didn't really seem clickable. So they were only added to anchors, they were never added to buttons. Once buttons are now part of CSS. So buttons have CSS nowadays, but they're a little behind support compared to other things. So for example, display flex on buttons is still new, so you'll sometimes see some strange behavior on some browsers when you do display flex on your buttons, and the recommended workaround right now is you put a span inside with display flex and not a div, because technically div inside buttons is invalid HTML, but browsers don't care about that anymore. Really. Convert to button challenge 2, display block. So we have a display block on this anchor, and that causes it to be on its own line in full width. We convert it to button, and now it's on its own line, but it's not really full width. Like you hover it over and you hover over it in the inspector, and it's like it's got this orange area that's trying to be full width, but not. So we have to add width 100%. But why? Well, if you look up what even is the display block, some simple descriptions will tell you it makes the element take up the whole width, but not on all elements. Like for example, if you added on if you added on an image, it's not going to stretch the image to be full width. It's an image has default width, which is defined by the amount of pixels in the file. And a button has default width defined by its contents. So display block's whole width won't override that. So summary, here's what we learned. There's big browser differences if you don't style your buttons. You'll have to watch out for that if you don't style them. Browsers.com, great for testing, especially old versions of phones. And buttons can behave differently versus anchors. And CSS logic and history is interesting. Thank you for listening. At Course Hero, we are hiring, got lots of jobs.
Do you remember when it was really hard to deploy static sites to the cloud? Like I'm talking about before Vercel and Netlify and others became a thing. Like to build a static site, deploy it to like CDN nodes across the world and serve them in a fast way was a hard problem. And then what happened was platforms like Vercel, Netlify, others, in a way brought the cloud down. Like they made this stuff quite trivial for developers. Like today, if I want to deploy a static site to Netlify, I just drag and drop a folder and it's live. We feel like databases haven't gotten the same love, right? Like bear with me. So say you're starting something like a job board, and you decide, okay, I'm starting a site like LinkedIn or Indeed or something, and I need a database. What kind of database do I choose? Do I choose a document store like MongoDB? Do I choose something with SQL and a bit more structure? Complexity. Let's just say we choose something with SQL. And really a good part of system design is thinking about, okay, how is this going to scale over time? Like if we have millions, billions of users, what's our story? How do we manage the scale and the complexity at that scale? So as we grow, you would probably want to scale vertically. You'd probably like throw more RAM at it, more disk space, so you'd scale up that way. But at some point you'd want to scale out. You'd want to scale horizontally. You'd want to have, if it's a job board, you'd be quite read heavy, right? People would be reading job posts a lot more than adding job posts. So you'd probably have some type of read replication story. With Postgres, you can do that. You can have like multiple read replicas, and data is like propagated between them and so on, but that gets complex. As you grow, you would probably need some type of in-memory key value store. Why? Well, because reading to and writing from and writing to disk is usually slow. It's slower than reading from and writing to RAM or memory. And so you need some type of like Redis or something in front of your database. So when your app requests data, it first gets it from Redis, but if there's a cache miss, then Redis gets it from your database and keeps it in its cache for next time, and subsequent things get faster, but complexity. If you're a job board, you probably need a search engine. Like people want, if you're searching for like TypeScript jobs, right? You'd want to type TypeScript and have a search engine deliver you results. But then if we add a search engine to this, you would have to have some way of like replicating data from your database into the search engine. So you'd need some type of like queue. You need like Kafka or something so that when data gets written into your database, it also replicates in the search engine. So that's complex. There's quite a bit of complexity if you want to build an app at any arbitrary reasonable scale today. At Zata, we're saying, hey, maybe this complexity doesn't need to exist. Maybe we can make the developer experience around this more approachable to everybody. So anybody wanting to start a job board starts a job board and focuses on the job board and doesn't have to worry about database complexity or data infrastructure complexity. So the goal really is to give developers such amazing developer experience that these things aren't really something we worry about. You just kind of give it data, it does its thing, you get a search engine out of the box, you get analytics out of the box, and so on and so forth. I'd love to show you that if you have a minute. So if we look over here on the screen, what we see is workspaces. And workspaces in Zata are similar to like orgs in GitHub or teams in like Netlify and Vercel. So we'd create a workspace for our company called Acme Classic. And what we'd do is we'd add a database. In this case, we'd say jobs. And this contains the database for our job board. What we can do then is, if we go to our schema, we can define a schema, a structure for our database. So obviously we'd need jobs in here. A job would have, for example, a title, that's a string, and maybe a description, that's a longer one, right? Maybe even a number for salary, maybe. Okay, so we have that. But then one job would usually have multiple applications. So we can add another table called applications. And we'd need some way to link applications to jobs. So what we can do is say this application is a link to jobs. So I'll add a column called jobs and I'll just do a link here. And what we can see is now these are connected. And of course, applications also have some data like name of the applicant and so on. Name. We'll do email. So we have a database, we have a schema, and it's ready to go. So let's insert some data. So I'll add a job. I will call it senior database engineer. And the description is must be amazing. Salary is 100,000 of something, Bitcoin. So I have this. And so now if we want to add an application for this job, we just add a record here. We can choose which job. And this is something, of course, our app will do for us as people fill out forms. The name is mine and the email is that, right? So we have data, we have it, but how do we now query this? So if I go to jobs, I can actually filter this, I can sort it, I can do all kinds of things, and the view updates here. But what I can do at some point is I can get a code snippet, and in this case, JavaScript. I can copy the snippet, and in any Node.js backend or something, I can paste it, and I have the data as expected. I can also curl this, I can do other things, and so on. So, like, we don't have to think about, Postgres, Mongo, we don't have to think about hosting it, we don't have to think about a lot of things. We get a database, we define a schema, we put data in, we get data out, bada bing, bada boom, my app is ready. So that's like the surface of how we're tackling this problem. But we also want to make the problem go away like later. Because as your job board grows, you're going to want to change the structure of your data. You're going to want to update your schema in some way. I'm talking about migrations. And database migrations historically have been super hard. Like, how do you write them? Where do you write them? How do you test them? How do you run them? At some scale level, running database migrations becomes really hard / problematic because they sometimes require like exclusive locks. So if you're updating your schema and you're running a migration, you can't like write stuff to your database. Can you imagine? Like, you'd have to have downtime and it's hard to navigate if you have a ton of users and complexity. Moreover, how do you like orchestrate migrations around code changes? Like, if you add something to your schema that code depends on, do you deploy the code first? Do you make the migration first? Complex, it's just hard. Migrations are a hard problem. They're like deploying static sites before Vercel and Netlify were a thing. At Zata, we're trying to make that problem go away too. And I'd love to show you that. So if you look over here on the screen, we just ran the code snippet. There's this thing called branches, right? We're probably not the first to come up with database branches, but we definitely want to focus on amazing developer experience around database branches. So if you go to branches, we can create another branch, and I'll call it, let's say I want to change my my schema and add pronouns to the applicants, to the job application. So I'll call it pronouns and I'll create it. And just like that, my database now has a variant in time, a branched version of itself, where I can go and update the schema. So if I go back to my database and I go to the pronouns branch here, you'll notice that there is no data. The data isn't copied between branches for security. We care about production security, and you really don't want to replicate that across branches, especially not like personally identifiable information, or PII. Anyway, so we're looking here at the pronouns branch, and I can go to this applications table, or I can actually just enjoy the schema view here and add a column called pronouns, right? And I can say it's a string. And so now if we compare branches, the pronouns branch has that, whereas the main branch, if I go to the schema view, does not. And so I can verify that this structure kind of works. I can even insert data if I want to. I can query the data using this get code snippet and make sure that the schema works in my app before then opening a merge request, having my team review it, kind of like you do in GitHub at the database level, and then merge it. When I merge it, a migration is run, but this migration is a zero downtime migration, meaning it doesn't lock up your database. Your users can still use it. There is no downtime. There's no need for a maintenance window. And also, it's a rolling deployment, meaning when you merge it, there's for a period of time 2 versions of the schema, before and after, available. And if you use the Zata API to interact with the database, if you send something from the old schema, it will just translate it to the new schema in real time. So it's a rolling deployment. You don't have to worry about, oh, which version am I talking to, while the migration is happening. So we really want to make these database problems go away. And so far, we are. And so how do you get involved? Well, we are a closed beta. So the name of the game is you go to zata.io, you can request beta access. And if you have a use case that needs it today, we can make that happen. You can also familiarize yourself with here. If we look at our docs.zata.io, this is public. You can look at it. You can look at our REST API and see what you can do and so on. And there's a really nice guide of like the things you would do most commonly with a database. We're really excited to make databases fun, safe, and predictable. One last way we're making databases, I'd say, more approachable to Jamstack and general software developers is working with production data. Like if you work with production data today, you're probably having to like SSH into something and use a CLI against production data, which may be unsafe. Maybe you enter Vim and you can't get out of it or something. As we showed you with Zata, it's a spreadsheet-like UI. You can edit it there if you want, or you could even say, hey, production is read-only, but let's make a branch and tweak things as needed. The name of the game is safety, comfort, and predictable, reliable developer experience at arbitrary scale as your startup needs, as your company needs. And with that, I want to say thank you so much for watching, and I hope this helps you kind of understand what we're doing at Zata. If you'd like to get started, as I said, zata.io, and we're hiring. So if you want to join us, zata.io/careers. All right, thanks so much for watching. That's been it. We'll catch you sometime soon. Peace.